Hey guys, it's Keith here from pixelcontroller.com. Dave and I would like to introduce you to our newest offering, which is this new board called the Falcon F Prop, a rather unique board, not a pixel controller in the classical sense, but more a board that allows you to run pixels and audio as it happens, but do it more as a standalone device. And I'd like to walk you through some of its capabilities and introduce you to the sorts of things that you might be interested in using it for. It's a fairly small board, barely 2 inches square, yet it packs a reasonable punch for such a small board and offers some unique operating characteristics that your regular pixel controller, while it can do a lot of what this can do, this offers it in a very different package with a very different user experience. So let me walk you through the capabilities and then I'll actually go in and walk it through in quite some detail. So if you just want to get familiar with what a device is, look, I'll spend the next 5 to 10 minutes on that. And then after that, the video will get much more in depth into exactly how to configure the board and all of that sort of stuff. So let's start with touching on its use cases. So what it is it's a standalone prop controller. It allows you to run a small display, such as, you know, if you were going along to a mini lighting conference and you just wanted to run a couple of props, this thing would be perfect at running those props. Or, you know, if at Christmas time you wanted to put some blinking pixels on your desk at work, this thing would be perfect for running those pixels and creating that display. It's also great for running tune to signs, particularly where you don't need the tune to sign incorporated into your display or sequence with the display. You just want it to run on its own all the time. It's perfect for those sorts of things. As we go through the board, you'll find that the board actually is able to interact with the environment with a number of sensor inputs, which allows you to have things like a door hanger, which is a pixel door hanger, which interacts with your guests as they approach your door and things like that, all possible with this. Also great for wearables. So if you want to attach pixels, or particularly seed pixels, I guess, to clothing, and you'd like something small and light and simple that could run those pixels, it's perfect for those sorts of elements. It's also great for interactive elements like Halloween props or selfie stations. Anywhere where you've got a prop of up to a couple of thousand pixels that doesn't need to be integrated with a broader show, doesn't need that network input, that's where this thing shines. It's also great for building pixel props for those that don't want to get into the technology. If you've got a neighbor who wants some pixels in their display but doesn't want to get into X-Lights, doesn't want to learn about FPP and pixel controllers, this thing, once it's built, is just plug and play. You plug it into the power and whatever it is programmed to do, it will just do. So we definitely see possibilities where people might want to go and build props and sell those props, or give those props to family and friends, etc., and use one of these boards to run it. And it's also great for things like architectural lighting, things like lighting under your soffits or under cabinet lighting. Very simple. You can definitely attach a few buttons to it if you'd like to be able to control the effect that displays, things like that, all possible using a board like this. It's not good as a pixel controller. It will not integrate with your display. Well, at least mostly, while you could definitely send a trigger or something to the board, it's not going to take pixel data. It's not going to listen to synchronization packets from your show player or anything like that. And it doesn't control DMX devices only. It is purely running pixels and outputting audio. So they're some sorts of the use cases that you might come across. So what is it? What's its features? It runs on 5 or 12 volts. You don't need to set any jumpers or anything. You just plug in the power and it will run. It has 2 pixel outputs. Each one could run 1024 WS2811 or compatible pixels. And it's fused with 5 amp fuses. Obviously, if you need more current, you can do power injection and the like, but you can't run it through the board. It does have stereo audio output via a 3.5mm jack. That's good enough for running headphones. If you want to run a speaker, you will typically need some sort of powered speaker or amplifier in order to drive speakers, as you would expect. It does have 6 control pins. Now those control pins can act as digital sensor inputs, or they can also be used as a digital output to, I don't know, drive a relay or to drive some other board which might be able to respond to those digital outputs. It does have an inbuilt vibration sensor, so mounted on the board is actually a vibration sensor. So if the board is shaken or moved, etc., it can trigger an event, and you can have it trigger a change in sequence or something. It also has 16 inbuilt timers. Now these timers aren't timers with clocks, as in, you know, they know what time of year it is or time of day it is. These are duration timers, so you can do things like trigger something to happen every 5 minutes or something like that. If you want if you want to play some audio every 2 or 3 minutes to tell people how to behave your show or something over a speaker next to your Tune 2 sign, you could definitely do something like that. It does have over 15 megabytes of onboard flash memory to hold sequences and audio. That actually gets you a fair amount of sequence data. Audio data not so much so, because the data will need to be as WAV files, and while you can make those WAV files reasonably small by lowering the bit rate and everything else, it's really not suitable for long audio files, at least on the onboard flash memory. You can use the SD card, and so if you do want to run larger sequences or larger audio, you would place them onto an SD card, and the SD card is also used to configure and program the board. In the case where you do load all the data that you need into flash memory, you don't need to leave the SD card in the device. And so, if you were building a prop for a family member or something and you just wanted to program the pixel data, you would load that onto the flash memory, pop out your SD card, and the device from then on is basically programmed and will just continue to work. That SD card's also used for upgrading the firmware, so it is firmware updatable, and we have been progressively adding new modes and new capabilities to the device over the last month or so, and fixing a number of version 1.0 bugs, as there always is. It's also reprogrammable, so once you've programmed it to do something, you can program it to do something at Halloween and then reprogram and reuse the board and have it do something different at Christmas. And it also has a number of inbuilt effects, so while you can definitely create any sequence you like in Xlights or any other software that can generate an FSCQ file, there's also a number of built-in effects that you can also take advantage of if you so wish. So it's quite a powerful little board for something that's not a Pixel controller. So here is the board. As I said, it is roughly 2 inches square. And if I can walk through the board down here, you do have the power input. This is the 5 or 12 volts. You just attach that, plug it in, and off it goes. These are your pixel outputs. The voltage rail here comes directly from the input, so if you're running 12 volt pixels, you will want to power the board with 12 volts, but if you're running 5 volt pixels, then you would power the board with 5 volts. Over here is your audio output jack, your 3.5mm jack if you're using the audio feature. And beyond that, there is the vibration sensor here. This is it's the little cylinder. It looks a little bit like a capacitor, I guess. And that's your vibration sensor. You can stand it up on end if you want to. Sometimes it can be a little bit more sensitive that way, depending on how you choose to mount the board and what sort of motion that you're trying to detect. This 4-pin port up here, this provides power output of 5 volts, but it also has a couple of the input sensor pins. The middle 2 pins here are the sensor pins. There's also another 4 sensor pins down here as well that you can use if you'd so wish. So a total of 6 input or output sensor pins, and depending on the type of sensor that you attach, they're going to be used differently. And we'll talk through how you configure it. And that's really all there is to the board, other than the SD connector here for sticking your little micro SD card in for programming and the like. And then there is an LED, this one down here, which provides a little bit of information about what's going on the board, and I'll show you that as well. Configuring the board. there's actually a text file that gets placed onto the SD card, which is read and loaded up during the boot up cycle. Basically, you place the SD card in with the configuration and you power the board on. It reads the SD card and programs the board in order to produce that text file, and all the details are laid out in the manual if you really want to understand it. But there is this tool that's available on the Pixel Controller website, which is suitable for programming the board. You can just come in here and configure everything, and at the end of it you just click generate and it will download into a zip file all the files that you need to place on your SD card to program the board. So let's do that. Let's configure the board to do some things using this programming tool. So a couple of things up here. You can give it a name, and that's really only used if you're saving it, which you can do to a local file, and then you can reload it into the tool. You can come down here and you can say how many pixels are going to be on each of the ports. You might not use both ports, you might just use one. You can set a global brightness. This will obviously reduce the brightness of whatever data that you might be sending out. This is fully bright, 255 is fully on. You can juggle with the color order. In my case, I do have RGB pixels. You can also do 3 or 4 channel pixels. This is mostly used when you use some of the inbuilt patterns that the board can generate, and if we know that they're 4 channel pixels, then we can output the data in such a way that those pixels light up correctly. And at the moment there is only the WS2811 protocol. We could add additional protocols later, but for now at least we're just doing the 2811s. Then there's the audio. If you're going to use audio, you can set the volume here, and if you are going to upload MP3 files, which you can do using this tool, it will get converted into a WAV file. So here's where you can decide exactly what bitrate you want to generate. 8000 is going to generate you the smallest files, and if you turn off the stereo you'll get a mono file which will be even smaller again. It really depends on what you want to do. The onboard files, these are the files that you're going to load up into Flash. Like I said, you get about 15 megabytes of these. To add these, you just click the add button, and then you can click on this and go and open a file and attach it. So, grab an FSCQ file like so. If your FSCQ file is being played with audio, it's really important that you add your audio file immediately after the FSCQ file, because when it plays back, that's how it's expecting them to be organized. But it's really as trivial as that, adding the files in. If you want to play files off the SD card, so you're going to leave the SD card in the device, you can come down here and add the files here as well. If you add an MP3 file here, it will actually convert the MP3 file to a WAV file on the fly once you add it. So you don't need to find separate software for doing the conversion to a WAV file. That will all be handled by the tool. The only thing I would flag is this works great when you just come in here and you're adding things. If you save the JSON file and you load the file later, because of browser security, while the file will appear here, the browser doesn't actually have access to it, because the browser prevents you from just writing random script and pulling files off your machine. And so you will get a warning when it generates the zip file that it can't include those files. As long as you've already put those files onto the SD card in a previous attempt or previous generate, that will all be fine. Otherwise, you are going to go and need to reattach each of those files, because otherwise, like I said, the browser won't allow the thing to have access to it. You then come down to the player and events. So player is the default mode. This is the thing that the board will do as soon as you power it on, and what it will continue to do as long as an event hasn't occurred. And there's a whole swag of different things that you can do here. The blank one will just turn off all the pixels, so it will actively send out blank pixel data. So if you want the board to basically look like it's doing nothing until an event occurs, this is a great playing mode to use. There are a number of things which will generate pixel data. So a color wash will just cycle through the colors on all the pixels. A rainbow does a pattern where all the pixels are a different color of the rainbow. Kind of similar to, you know, something like a butterfly effect that you might see in your sequences, although actually it's not a butterfly effect, it's a rainbow pattern. The red, green, blue, white will just cycle through those colors. The color one here allows you to actually choose a color that you want all the pixels to turn, and then there's white, which just turns everything on white. And then you've got your various play FSEQ. So you've got your animations playing purely audio and playing the pixels plus the audio file in a synchronized fashion. The first three here will play it from the onboard files in the flash memory, and then the last three here will play from the SD card. And then you have an effects. This is very similar to you know, the WLED effects and the things like that, which are built into the board as well, and you can play some of those. And so in this case here, I don't know, I might do a rainbow effect. There's no parameters, so it's just rainbow here. And then I want to actually play this sequence when an event occurs. And that's as simple as adding an event down here. And when you add an event, and you can add, I think there's like 16 of these that you can add on the board, you come in and decide what you want to do. In this case, we're just playing an animation from Flash, so we'll choose that, and we're going to play the baubles animation. Now, you can choose randomly, so if you've attached multiple up here, you can say I want to play a random one, or sequentially go through and play them, either way. In this case though, we're just going to play that particular file. You then get to choose how it's going to be triggered, and there's a huge number of options here for how you trigger it. The vibration sensor is obviously the easiest to do because it's built into the board. You don't need to do anything fancy. You can attach an ultrasonic sensor. Now that's a little bit unusual, and I'll show you a picture of how you do that. This is one of these HCSR04 ultrasonic sensors, and you basically attach them in this method across those the 4 pins here, and essentially this allows you to do distance sensing. And you can actually tune over which distance this thing will detect, and if anything gets within that distance, then the event will be considered trigger, and the sequence in this case will start to play. Now, you don't have to use ultrasonic sensors. You can use PIR sensors or audio sensors or reed switches. There's a whole bunch of different sensors that you can use. This is an audio sensor that you can also grab on AliExpress. This one happens to have a potentiometer and a digital output pin, so this allows you to set the audio sensitivity, and then you can just attach that. In this case, we've chosen to attach it to one of these pins down here, and you can configure the board to essentially trigger when the audio reaches a certain level of loudness using a sensor like this. So yeah, so these sensors here, there's a whole bunch of normally open or normally connected, or a whole bunch of things like this, all covered in extent in the manual. Normally connected means that it's normally producing a 0 voltage, because connected is considered the pin, the input pin is shorted to ground, so normally connected would say that there's a low signal on that, and so as soon as that signal goes high, that signal would be considered triggered on sensor 1, and the event would occur. The normally open one, that's where the pin is normally high, so if you've got a particular sensor, or you've got something that's normally open, like a sensor mat or something, and when someone treads on it, it closes, then you'd use something like a sensor normally open, those sorts of things. There's also timers, so you also have the 16 timers that you can use, which allow you to say, I want this event to occur, you know, every 5 minutes, and you can even specify a period during which you want it to randomly occur as well. So there's lots of different options here in the sensors. We can just use the vibration sensor. We should generally leave the sensitivity as 0. That's the most sensitive. That basically triggers the first time the vibration sensor goes off. If you increase this sensitivity, it's looking for multiple triggers, i.e. a fair amount of shaking before it's actually going to go off. Priority allows you to arbitrate between multiple events, so multiple things might go off, and so you can set something with a higher priority, in which case that event will take precedence over any other events, including anything that might already be running, and force that event to happen. You can also set minimum gaps, etc., so that these events don't occur too often. So for instance, in this case here, this vibration goes off and it's going to play this sequence. This sequence is actually quite short, but if I don't want it to go off again for another minute, I can put 60,000 in milliseconds here, and now this will only go off once a minute. No matter how many times it gets shaken, it'll only go off the once, and then it will stay quiet for a minute, and then after that minute's up, then it's able to go again. You do have some ability to do things like suppress events. So if you've got, if you want to attach a switch which allows you to turn an event off so that it can't occur, maybe you don't want it to happen when you toggle a switch, or you could put a light sensor or something on that and say, look, I don't want this event to occur during the day, for instance. I only want it to occur at night, and so you could easily use something like that. And then it's an immediate action, just meaning that it will interrupt whatever's going on, which in this case is really important because this thing doesn't really end. It just stays displaying the rainbow forever. And that's really all you need to do. That's the entire configuration. We just click generate, it creates a zip file. All right, and if I go to my downloads, it's created a zip file, and this is that zip file containing the configuration, the 49 pixels, the baubles.fscq, the rainbow. The event is going to play an FSCQ. It's going to play the first file, which is this one here. It's going to trigger on the vibration, and it's going to be a gap of 60 seconds. Now you could write this file manually. You don't need to generate it this way, but it's obviously a lot easier to generate it this way than any other way. I will need to make sure that baubles.fscq file is on the SD card when I place it into the board and apply the power. So let's see what it looks like then when you do that. So here we have the board, the SD card's being placed in it, the power is not currently on. We're going to apply power and the board will program. So when it comes on, this LED here starts, it glows, it starts going, basically it fades in and out. And then once the board has programmed, which it now has, the board stops and it flashes on a regular once a second flash on and off, and that tells you that the board is now running. If the board doesn't program correctly, typically what will happen is it will just either stay with whatever the old configuration was, or in some cases the LED will flash a slightly different pattern indicating that an error has occurred. Essentially it will flash on and off 8 times and then go silent for a little bit and then do it again, and that shows you that it's in an error state. That will very rarely happen. More often what will happen is the configuration that you're trying to load just won't take, and you'll have to go and work out why it didn't happen, and I'll show you how you do that. So if I show you one more time, here's the LED fading on and off. Depending on what you're programming, that can take quite some time. If you're loading files into the flash memory, which this particular configuration, when I recorded it, I don't think was, so it programs quite quickly. If you're loading into the flash memory, this can actually take quite some time to go through. If you do think it's stuck, it's harmless to turn the power off and on again. It doesn't actually go back to the beginning. It'll actually pick up from where it left off. So it's quite harmless to power cycle the board while it's programming, and it will just pick up again and reprogram it. This is the same way that you also update the firmware. You would download the new firmware from us, and I'll show you that shortly. Place it onto the SD card and apply power, and it would read it in and program it on power up. So that's how you configure the board. It's really as simple as that. Troubleshooting the board is all driven by the files which are on the SD card. So when the board is powered on, it will write two log files. The first one is the FEP BL.log. Now in this case I actually think I had a Falcon Controllers firmware on the file, and it detected the fact that that firmware was invalid for the board, and so it just refused to load it and ran the firmware. So that's how you can find any errors that might occur during the load. That's the bootloader, the first program that loads. When it goes to configure the board, it also produces a log file here where in this case it's loading a configuration. This one had a couple of FSCQ files that were being loaded with one event that were being loaded in. This will also tell you how much flash you've used. In this case, I've loaded two sequences, and I've only used 16 kilobytes of 15,000 kilobytes of memory. So there's still a lot of space left on the SD card after I've loaded this. So this will come through and it just basically tells you the configuration. Typically, if there is an error in your configuration, something that causes it not to load correctly, it would appear up at this point here, and it will tell you the parameter that it's trying to load and why that parameter failed to load successfully so that you can troubleshoot it. So it's a little bit difficult, or it's a little tricky to do. I won't say difficult, it's a little tricky to do, obviously, because you now have to flick backwards and forwards to this file once you've programmed it. But once it's programmed, of course, it's good. And if you keep those files ready for the next time you might want to reprogram the board that way, you can just apply them again and they'll pretty much work every time. There's no reason why they won't. So once you've got a configuration that works, replicating it many times is extremely easy to do. So that's how you troubleshoot the board. You can turn on logging. So when you generate the file here, if you're having issues when it's playing, you can turn on debug logging down here. Normally what happens when the board's running is it will reach this point here where it says the event player is running and nothing else will get logged. If you do turn on logging using this option, then it will do some additional logging while it's trying to play. That can be great for working out any problems which aren't occurring during the initial load but seem to be occurring later on. You will obviously need to leave the SD card in the board while that's running. And I wouldn't leave it on long term. Once you've worked out what the problem is and you've got a good configuration, I would turn that off. It generally won't cause a great deal of harm. It's not like it logs excessively or anything, but obviously you don't want to be leaving the SD card in if you don't need to. So I would generally turn that off. And that's pretty much it. Then you've got updating it. So there is a GitHub repository under Pixel Controller called FProp Issues. In this repository, you will find the manual here. You can also access the manual from the product homepage, but the manual is here and we do update that from time to time. The latest firmware is also here along with a change history, so you can see what bugs or what features we've been adding over time to the firmware. If you do want to download the firmware, this is always a little bit tricky. If you go into the firmware, click on it, you really can't see anything. But if you come over here to this download button and click that download, it will download the FL3 file, which you can then place onto your SD card. Please make sure there is only one FL3 file on the SD card. The board will just find the first FL3 file that it sees and it will try to load that. It does check to see that the FL3 file is for that board, but if you've got multiple files for the board but different versions, it can be a little hard to work out which one it's loading, and so you want to make sure you only have one of them on your board. But yeah, it's fairly easy to do that. And the instructions, if you forget this, there are those instructions there for how to download the FL3 file if you have forgotten. The product page on the Pixel Controller website is here, where it has a high level description and everything. You can order it here, and you can access the manual here. It's picking the manual up from GitHub, so it is the same manual, but in this case it actually downloads it for you. So you'll find that in your downloads, which you can then open. And this is a pretty comprehensive manual about the board. It has all of the things that we've talked about. It also goes through and talks through all of those configuration settings, gives examples of different types of sensors that you might want to use. It does show you some simple wiring diagrams for how you might want to connect these things up. And then the configuration, on top of mentioning the tool which we just showed, it does actually go through and give you a full rundown on all the settings, examples, explains how the files work, etc. Now, 90% of you will probably never need to touch this. You'll just use the online configuration tool. But there is a full reference here for all of those settings and what they do and how to use them and so forth. So a fairly comprehensive manual that you can jump into and understand. There's also something here that talks about, well, how you configure your FSCQ files, which in Xlights is really just a matter of creating a layout that contains your props. They should be organized such that the first prop starts, this would be the prop that would be on port 1, and it should start on start channel 1, and then the next prop should then start immediately after it. This could be on pixel port 2 or pixel port 1. It's really up to how you want to configure things. There's only about 98 pixels here, so you could run both of these off port 1, or you could tell it that these 49 pixels were on port 1 and these 49 pixels were on port 2, and the board will make sure that that data is output to it. And that's it, guys. It's really as simple as that. We're hoping that that you'll all love this board and find some really interesting use cases for it, and we're excited to see what you might do with them. Thank you, everyone.